In the deepest, near-freezing waters of the Arctic Ocean, life moves at a glacial pace. Out of this icy darkness, a massive shape emerges, moving so slowly it barely registers as alive. Somewhere beneath the ice tonight, a shark is breathing that may have been alive when Galileo first looked at Jupiter. This is Somniosus microcephalicus, the Greenland shark. It is the longest-lived vertebrate on Earth, achieving a lifespan of 400 years by adhering to a pace of extreme evolutionary slowness. Surviving 4 centuries makes this creature a living timeline of Earth's history, a strategy of minimal energy expenditure that sustained the species for millennia. To understand how a body lasts 4 centuries, we have to look at where it lives. The Greenland shark patrols the dim depths between 100 and 1,200 meters. Down here, the water temperature hovers right around freezing, which forces the shark's metabolism to run at an absolute minimum. This chart shows exactly how that low metabolism affects movement. Greenland sharks swim at an average of 0.34 meters per second, the slowest swim speed for any fish their size. They are practically drifting. Measuring the exact age of a fish without bones is difficult, but researchers found a unique clock hidden inside the shark's eye lenses. They tracked the bomb pulse, a spike in radiocarbon dating back to mid-century atmospheric nuclear weapons testing, to determine when the youngest sharks were born, and then calculated the growth rate backwards. This timeline illustrates the results. The largest animal was estimated to be nearly 400 years old. But this longevity carries a cost. The timeline shows they reach sexual maturity at 156 years, spending a century and a half simply growing. Extreme physical slowness translates directly into extreme chronological endurance. By burning almost zero energy, the shark buys itself centuries of time. That longevity is written directly into their DNA. At the molecular level, the Greenland shark genome is roughly twice the size of the human genome, and more than 70% of it consists of jumping genes. Jumping genes are segments of DNA that can copy and paste themselves throughout the genome. In the Greenland shark, these elements multiplied a specific set of DNA repair genes, creating a massive cellular maintenance system that completely stalls the aging process. But how does an animal this slow acquire fuel to maintain its massive body? As they grow, their diet shifts. Young sharks eat mostly squid. Adults over 2 meters eat fish and even fast-swimming seals. To catch prey that can swim far faster than they can, they rely on stealth. When researchers find remains of larger mammals, like polar bears, inside their stomachs, it is the result of scavenging sunken carcasses. It is a perfectly balanced biological loop. The shark spends almost zero energy to slowly hunt and scavenge in the dark, while its massive genome endlessly repairs the cellular damage of time. For millions of years, this slow rhythm worked flawlessly. But deep time is now colliding with the sudden, violent intrusion of the Anthropocene. An animal born long before the Industrial Revolution simply cannot adapt to the sudden arrival of mechanized fishing gear. As industrial fleets drag nets across the deep ocean, the casualties mount. Today, global bycatch is estimated at least 3,500 Greenland sharks every year. This creates a mathematical crisis. Because an individual shark requires 156 years just to reach reproductive age, it cannot replace its numbers on a human timescale. It is exactly why the species was listed as vulnerable by the IUCN in 2020. Losing this shark means the permanent disappearance of the longest living memory on Earth. Some of these ancient lives are measured in slow centuries, yet they can vanish in a single human breath. Beneath the ice, the slow shark waits.